In our previous video, we discussed about the projection. We discussed the basic principles of first and third angle projection. We discussed the orthographic projection, and we see that how in first and third angle projection what should be the position of different views with respect to different view. Now, in continuation with the orthographic projection, now we come to the projection of points in the first quadrant. Means in this first figure, we have a point A, and that point is located in the first quadrant. Means it is in front of the VP at a distance D, which is shown here, and it is above the HP at a height of h from the horizontal plane basically. Now if we take the projection, because we are discussing here the orthographic projection, so we assume that the rays are coming, or the observer is at the infinite distance, and all the rays which are falling on this point is parallel to the plane of projection. So if we take the projection of this point on this vertical plane, so this is representing by the symbol a dash, and when we view from the top side, so we are getting a horizontal projection of the same point capital A as small a. So small letters or alphabets we are using for projection on the horizontal planes, and dash symbol means here we have the point A and the projection is a dash. So dash symbol of the alphabet we are using to take the projection or to represent the projection of any of the object on the vertical plane. Now we see that A and A dash are the projection of this A point on HP and VP. Now because it is a three-dimensional view, because we have to locate the point in first quadrant, now we have to represent this on the two-dimensional sheet. So the second figure will show the representation of the projection of the same point A on the two-dimensional sheet. Now what we have to do for this, we have to rotate this HP by an angle of 90 degree in the clockwise direction as shown by these two arrows. Now after doing this VP and HP now are in the same plane, and this XY is representing the line which intersecting the VP and HP. Now if we see that this A dash point is above XY line, and this A point is below the XY line, and the distance of this A point is distance D, and the distance of this A dash point from the XY line is H. So this is as per the first angle projection when the when the point is in the first quadrant. Now if we consider the point is in the second quadrant, means here we are considering a point B which is in the second quadrant, means the point is behind the vertical plane and this is above the horizontal plane, and the distance BO here is D, and the distance B dash O here is H basically. Now if we take the projection of this point, okay, and the observer is again observing from the infinite in the as per the orthographic projection, so here we see that the plane of projection is in between the object, or means the point, and the observer. So when we take the projection of this point on the vertical plane, it is representing by the dash symbol B dash, and when we view from the top side, the projection of this point B on the HP is B. So this B and B dash are the projection of this capital B point on the horizontal plane and on the vertical plane. Now again this is a three-dimensional view. To represent the projection of this capital B point on the plane sheet, we have to rotate the HP by an angle of 90 degree in the clockwise direction. So when we rotate this HP in the clockwise direction by an angle of 90 degree, now these two plane HP and VP are coinciding with each other. Now you see that this is the XY line here, this XY line representing the intersection of both the planes HP and VP, and when these two planes are coinciding, so depending upon the distance H and D value, so here we assume that D value is more than the H value. So with respect to this XY line, this B point will be above the B dash point, because this B dash distance is H and the distance of this B from this O point is D basically. So this distance is higher. So D distance is higher as compared to H. So the B point is above the B dash point, and both the points are on the same side basically, because we rotate this horizontal plane by an angle of 90 degree, and this VP and HP now they are coinciding with each other. So this is the projection of the points in the second quadrant. Now if the point is in third quadrant, now how we are getting the projection of that point? So here we are considering a point C, and that C point is in the third quadrant, means this point is below the horizontal plane, and this point is behind the vertical plane. This is the location of this point C here, and all the distances, if we see the distance of this C point is D with respect to the xy line or with respect to the O, and the distance of this C point with respect to the horizontal plane is H. Now if we take the projection of this point C, so again we use the concept of the orthographic projection or the basic principles of orthographic projection, and we see that the observer is at the infinite distance. Now in this case, the planes are assumed as a transparent, and the planes are in between the point and the observer. Now when we take the projection of this point C on the transparent plane, that is HP and VP, so we are getting a vertical projection C dash on the vertical plane, and when we view it from the top side, we are getting the projection of this point C on the horizontal plane, which we assume as transparent. So the projection of this capital C point is small c on the horizontal plane and C dash on the vertical plane. Now this is again in 3-dimensional. We have to represent them into the 2-dimensional sheet. So what we do, we have to rotate the horizontal plane by an angle of 90 degree in the clockwise direction. Okay, and in this situation we see that this HP and VP are in the same plane. So here this is the XY line, which is representing the intersection of both the planes HP and VP, and the projection C here, which is on the horizontal plane, will be above the XY line, and this is at a distance of D. And the projection of this C dash, which is representing the projection of this point in the vertical plane, this is below the XY line, this is at a distance of H. So C and C dash are representing the projection of this point C on the horizontal plane and on the vertical plane. Now here the projection on the vertical plane is below the XY line, and the projection on the horizontal plane is above the XY line. The last case, if the point is in fourth quadrant. So here we see that point E is in the fourth quadrant, means this point is in front of the VP and below the HP. And again the distances of this point is D with respect to point or XY line, and from the horizontal plane the distance of this E point is small h. So when we take the projection, again we use the concept of the orthographic projection here, and when we use the when we take the projection of this E point, so we assume that the projection of this capital E point on the vertical plane is E dash, and when we view it from the top side, so we assume that the plane as the horizontal plane is a transparent plane, and the projection of this point E on the HP is E. Now again, as per the rule, we have to rotate this horizontal plane by an angle of 90 degree in the clockwise direction, so we can rotate it. Now when we rotate this plane HP by an angle of 90 degree as representing by the arrows, so these vertical plane and horizontal plane, now they are coinciding, means they are on the same side and they are below the XY line. So XY line representing the intersection of both the planes, and here we see that both the projections are on the below the XY line, on the same side basically, and it is below the XY line. So this E dash will represent the projection of the E point on the vertical plane, and small e is representing the projection of the same point capital E on the horizontal plane, and they are at a distance of h from the point O, and they are a distance of d from the xy line. So this is representing the projection of the point when it is in the fourth quadrant. Here in this video we learn about the projection of points when the point is in the first quadrant, second quadrant, third quadrant, and in the fourth quadrant, and we see how the projection of the point is representing on the 2-dimensional sheet. If you understand the basic concept of projection of points with this video, please like, subscribe and share this video. Thank you very much.